All right, it's a good day in pre-calculus, and it's a Friday. We've got the Cartesian coordinate system. You're going to notice everything that we are talking about today, total and complete review. Plot data on the Cartesian coordinate plane, and we have used the properties of absolute value. No one used the distance formulas, whether or not we're talking about on a number line or on the Cartesian coordinate plane, two-dimensional. No one used the midpoint formula. No one used the equation for circles. So like I said, totally and completely review. Good stuff. Almost a day to take a break, right? So here we are with the quadrants. And if you've ever wondered why this is counterclockwise, why this seems backwards, well, it's European. This was developed by René Descartes, and he was a French guy. So we start over here with quadrant 1 and make our way around 2, 3, and 4, with the origin, of course, at 0, 0. And here is Mr. René Descartes. The Cartesian coordinate plane, named after him, and it is also called the rectangular coordinate system. So it's a 2D system that we graph on. Let's see what we're supposed to do here. Ooh, scatter plots, yeah. Plotting data on U.S. exports to Mexico, the value in billions of dollars of U.S. exports to Mexico from 2000 to 2007 is given in table P.2, and we can see that down there. Plot the year export value, ordered pairs in the rectangular coordinate system. So years are supposed to go in here for our x's, and then we're supposed to use our U.S. exports in billions of dollars for the y. So to get going, I'm going to make ourselves a Cartesian coordinate plane. As I'm drawing this, I want you to think about why I'm not putting any other quadrants on here, why this is just quadrant 1. And of course, that's because everything that we're going to be graphing is from a table that involves real numbers, and all of this data is positive. So now what? Well, we need to spread out our years down here on our x-axis, and we need it to go from 2000 to 2007. I'd like to have a little bit of room, so maybe I'll go every two. This is a 20 by 20 grid, by the way. So we'll make this one 2000, this one 2001, 2002, 2003, etc. And we know these are not the toughest things we're ever going to do. It's just, it's kind of putsy, but we know what we're doing. And that's what we have to do. We have to see the scatter plot so we can see how the data are related. So over here we would have US, US, doesn't look much like a U. Exports, and we definitely want to tell people billions of dollars. And we know that. We were working with scientific notation earlier this year, and people missed in a table that it was in millions. And, we have to catch that stuff when we look at tables. It's important. If we're going to be educated consumers and we see graphs, we need to know what they're doing. So I have to decide if I want to start with 0. And I notice that this data starts at 97.4. So I probably won't start at 0. To do that, remember we have to indicate a break in the corner, and there's lots of different symbols, but basically you just have to show, hey, I understand that there should be a break here. And then I'm thinking I might start with 95, and I have to go to 136, so maybe I will go 95, 100, 105, and just continue on going by 5s, but maybe I'll space that out a little bit too, so every 2 of these. All right, so 95, 100, 105, 110, 115, 120. Oops. I guess I was in a hurry to get done there. Started going by tens. There we go. Because those intervals need to be consistent. I know that some of you have had science classes with Mr. Nijellik, and he likes to use all of the space. You know, he likes you to use intervals that will give you the biggest visual benefit. You know, you'll be able to see everything individually. So now we just graph those and graph those points. So we use 2000 and 111.3. So we have to figure out about where that would be and put a dot. 2001, 101.3. 2002, 97.5. Halfway in between there. 2003, 97.4, so just a little bit below there. 2004, 110.8. A little bit lower than our 111.3 from earlier. 2005, 120.4. 2006, 134. And 2007, 136. Ta-da. So we have it all up there. And usually what we're using scatter plots for are to figure out, is there a relationship between the data? Yeah, a little bit maybe here. You know, we might be able to figure out a graph that could go through all of those points and make this work. But our job today is just make those scatter plots. Get them on there. Take a peek at them. So a scatter plot is the plotting of data pairs, x's and y's, on a Cartesian coordinate plane. We just created a scatter plot of the data for U.S. exports to Mexico. And I do want to let you know that I always have graph paper in the wire baskets over against the wall that's the hallway wall, I guess I should call it, underneath the frog. So there's 3 different wire baskets there with graph paper in them, and you can help yourself to those at any time. But for now, stick with the lesson and let's keep rolling. So the absolute value is the next piece. That was another objective that we had for today. The absolute value of a real number suggests its magnitude, and its magnitude is its size. So the absolute value of 3 is 3. An absolute value is the distance something is from 0 on the number line. So the absolute value of -5, that's 5. And I use the example that if we're going to Big Lake, we're going to travel to Big Lake. We're going to say, hey, we went 13 miles over to Big Lake. Wanted to try out their Dairy Queen. Well, on the return trip, we're not going to say we went a -13 miles. That doesn't make any sense. So the distance something is from 0 is distance, and it needs to be positive. So absolute value of a real number, this is a definition that Mrs. LaRue has talked about that you need to understand when you get to calculus. And it'll be very useful to you when you're working through calculus problems, and that is the absolute value of a real number a is just a if a is positive. So they're saying if you take the absolute value of 3, 3 is a number that's bigger than 0, you're just going to get 3 back. However, the absolute value of a, if a is negative, like this little -7 I have here, is not going to pop out as a -7. You can see how putting another negative in front of that would give you what you want. The negative of -7, and that of course would be 7. So by the definition, if we put a negative number in there, we need to think of the fact that we can represent that with a negative of a negative. And then of course we have a neutral number, and that's going to be 0. So this is just telling us that the absolute value of 0 is 0. That's not a shocker. You have not moved off of 0, so you have not moved any distance. Now, on the next page, using the definition of absolute value, we want to figure out what these are, which means we want to write what this would look like without those absolute value bars. And we take a peek at the first one and we say absolute value of -4. Are you serious? That's 4. And then we go to b and we go, uh-oh, help, help. Well, no, we don't need to cry help. Here's what we know is going to happen. We're going to take pi and we're going to subtract 6. We're going to get something positive or negative. Well, we need to know more than that. We know this is 3.14 blah, blah, blah here, and we're subtracting 6. We know that's going to be negative. So we can't do that. We need to do the negative of pi minus 6. By the definition of absolute value, that'll be negative pi plus 6. But we're going to write that as 6 minus pi. So see how originally it was pi minus 6, but if we plug that into our calculator and we plug 6 minus pi into the calculator, we'll get the exact same number. It's just that the first one, pi minus 6, would be negative. And we can't have a negative because we're talking absolute value. So that's when this definition of absolute value comes in really handy, is when we're dealing with things along this line. So again, you could kind of use your calculator and figure that out too, but this was more about, can we write this so it would make sense? And that would be by turning those around. Properties of absolute value, well, here we go. It says that the absolute value of A is greater than or equal to 0. Of course it is. It has to be positive. It says that the absolute value of negative A is the absolute value of A. Yeah, gonna work. And then in 3, we see something very cool. We see that we can split absolute value factors apart, just like we can radicals. We can do that. Excellent. Same thing, number 4. We can split it apart. But again, we've got that little domain restriction that says, yeah, you can, but you can't let B be 0. And we're used to that by now. We know we can't divide by 0. Silly us. Distance formulas. What if you're looking at the distance between 2 points on the number line? Well, if you're just looking for the distance between 2 points on a number line, then all you have to do is subtract one from the other and then write down a positive value, because we're talking distance, which is absolute value. So it doesn't matter if, like you see right here, you take the absolute value of A minus B or the absolute value of B minus A. You just have to remember in the end that you want a positive number. That's what we're doing. So down here it says the distance between -1 and 4 on a number line is 5. And that would be because the absolute value of -1 minus 4 is 5. But what if we did the absolute value of 4 minus a -1? We're going to get 5 either way. So the order of the subtraction does not matter when we're using absolute value. We just want to know how far is it from here to here. That's the distance we want right there. That's what we want to know about. Now, that's one-dimensional. You know, that's, hey, I'm giving you a number on the number line. One-dimensional. But the distance formula for the coordinate plane, and hopefully when you look at that, you remember that one, is a little more complicated. And that's because this is derived from the Pythagorean theorem. That's exactly where this comes from. So here's what we know. This is a right triangle that we see in this picture. And in any right triangle, the sum of the squares of the two sides is equal to the sum of the hypotenuse squared. That means that if we take the distance between x sub 1 and x sub 2, which is right there, and we add that to the difference between y sub 1 minus y sub 2, and each one of those is squared individually before we do that, then we'd take the square root, and that would give us what we see right here. So again, what we're saying is it would be the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. And that's kind of bothering me because a lot of books will put the 2 in those first positions. It doesn't make any difference. It makes absolutely no difference. So if we think, ew, absolute value inside all this radical stuff, well, what could I do? I mean, can I drop the absolute value? Sure I can. Those are going to be squared. If they're going to be squared, we're guaranteed that it's going to come out positive. So we can just put x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Now that's not the derivation. You know, this says derive the distance formula, use the above visual and the Pythagorean theorem. So I was talking you through the process, but now it's time to derive. We go back to the picture and we say, okay, all we know is this is a right triangle. Well then, this squared plus this squared has to equal this squared. Yeah, so d squared has to equal the absolute value of x sub 1 minus x sub 2 squared plus the absolute value of y sub 1 minus y sub 2 squared. So far, so good. And then we say to ourselves, self, I don't need those absolute value bars because I'm going to be squaring this. And then we say, almost there. I almost have the distance formula, but I can't have d squared. It has to say d. Well, yeah, let's take the square root of both sides. Then bam, we've got it. There's a distance formula right there. You know, it doesn't take a lot to derive it. We already know the Pythagorean theorem. We know how to use it. So let's go to example 3. Finding the distance between 2 points. Find the distance d between the points 1, 5, and 6, 2. So this is two-dimensional, and that means I'm going to use my little formula. D equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. So let's see what we get. Doesn't matter which one of these you make x sub 1, y sub 1, and which one you make x sub 2, y sub 2. Just do it consistently so you're not messing up. So the square root of 1 minus 6 squared plus 5 minus 2 squared. And we'd have to do the parentheses first. So this would be negative 5 squared plus 3 squared. Alrighty, so that's the square root of 25 plus 9. Well, that is the square root of 34. And the last thing to do would be to simplify that, if we could. You know, if there were a perfect square that divided evenly into 34, then we would do that. But this is a perfect answer right here. D equals the square root of 34. And if we had to, we could punch it into the calculator if we see that all the answers are going to be decimals. In pre-calculus, we try to teach you what they do in calculus on the AP exam, and that is to go to 3 decimal places. Now, they do tell you that you can round or you can truncate, but I'm going to have to talk to you more about what truncate means. So we are just going to get used to rounding to that 3rd decimal place. Midpoint formulas. Midpoint, it's the average. I mean, that's what it is. It's midway between. So the midpoint formula on the number line means we're just going to take the 2 numbers that we see, add them together, and divide by 2. That's it. So down here it says, finding the midpoint of a line segment. And the line segment means it's one-dimensional. And it says the midpoint of a line segment with endpoints -9 and 3 on a number line is blank. Well, a little formula was right up there. That's going to be -6 divided by 2, which is -3. So there it is. There's our midpoint. We take that little box away, and we see that the distance from -9 to the midpoint at -3 is equal to the distance from 3 to -3. Right there. You know, they're both 6 units. Midpoint, halfway between. Last year in geometry, you did midpoint with 2 points. And what do? Well, what you do is you find the average of the 2 x coordinates. So you add the 2 x's together and divide by 2. And then you find the average of the y coordinates. And there it is. If you have 2 points, A, B, and C, D, you're going to take A plus C and divide by 2 and get your new x coordinate. And then take B plus D, your 2 y coordinates, and divide by 2. So example 5 says, finding the midpoint of a line segment, the midpoint of the line segment with endpoints at the ordered pair -5, 2 and the ordered pair 3, 7 is. Well, here's an x, here's another x. Divide it by 2. Here's a y, there's another y. divided by 2. And we're just going to do the math. So negative 5 plus 3 is negative 2. Negative 2 divided by 2 is negative 1. 2 plus 7 is 9. 9 halves. And there it is. So negative 1, comma, 9 halves. That's where the midpoint would be. Now, all you need to do when you're thinking midpoints is think average. You know, we have to find the average. There's 2 of them. Add them together and divide by 2. So again, we've talked about absolute value a little bit. We talked about scatter plots. We have talked about the distance formula. We have talked about the midpoint formula. So we can cross a lot off of our objectives, but we're not quite done. And that's because we have equations of circles. Well, equations of circles are fun because they're nice and easy too. So this says use the distance formula and figure P.14 to derive the equation of a circle. So how should one do that? Well, the distance formula tells us r. So r equals the square root of, well, let's see, this would be x minus h squared plus y minus k squared. Well, I don't think that looks like the circle formula that I remember from geometry. Well, no, but it will very shortly. Because here's what we're going to do. We're going to get rid of that radical. And we're going to say r squared equals x minus h squared plus y minus k squared. And that is how we get the formula for a circle. Pretty cool. And what we see here is we have to put some things in. Not a lot, but we have to put some things in. H and K, that's going to be the center of the circle. And this, R value, is of course the radius. And most of the time when you see this in the geometry books, it's listed backwards here, like so. The quantity x minus h squared plus the quantity y minus k squared equals r squared. But boy, is that a nice formula to work with. Absolutely, absolutely nice formula to work with. So the standard form for the equation of a circle, center hk and radius r, is right there. And yeah, like I said, normally the r squared is on the right-hand side. So let's see what they want us to do. It says finding standard form equations of circles. Find the standard form equation of the circle. Oh, okay. So if they want a circle, I'm going to pull out my little formula here. And I'm going to substitute in h and k and r. But if I put this in for h, it's going to be x minus a negative h, and that just looks gross. We're going to simplify that and make that x plus 4 squared. And then we'll have a little y minus 1 squared right there, and 8 squared is 64. And it's done. Whew. Gotta love it. That's a circle. All right, how about B? Oh, okay, center is at 0, 0. So x minus 0 squared plus y minus 0 squared equals 5 squared, which is 25. That just looks like more than I need. Yeah, we know what x minus 0 is. It's x, so it's going to be x squared. Y minus 0 is just y, so it's going to be y squared. X squared plus y squared equals 25. Woohoo! Yeah, circles aren't tough. They're just not. So, got to be something that'll be a little challenging here, isn't there? Well, our applications say example 7, you're using an inequality to express distance. We can state the distance between x and negative 3 is less than 9 using an inequality. Well, what inequality? The distance between x and negative 3. Okay, so we'd have to do absolute value of x minus a negative 3, and then it says is less than 9. Oh, is less than 9. Well, we might want to pretty that up a little bit. That minus a negative, that's a waste of space. That should be x plus 3. And we need to do that. In pre-calculus, we need to be able to do that. We need to simplify that. In fact, you'll lose points if I see minus a negative on stuff or plus a negative and that kind of business. We have to be able to transition smoothly into simplifying. So there was an application. Now, what else? The Pythagorean theorem and its converse are both true. The Pythagorean theorem is what tells us that in any right triangle, the sum of the squares of the two sides equals the square of the hypotenuse. The converse says, you know what? If you do the math and the two sides, when you square them and add them together, they add up to the radius squared, you've got yourself a right triangle. So it works forwards and backwards. If the sum of squares of the lengths of two sides of a triangle equals the square of the length of the third side, then the triangle is a right triangle. And I know it says third side, but we know that's called the hypotenuse. So that's how we know that we have a right triangle. And 8 says, use the converse of the Pythagorean theorem and the distance formula to show that the points negative 3, 4, 1, 0, and 5, 4 determine a right triangle. Okay, I'm going to need the side lengths first. So I'll need to know how far it is from negative 3, 4 to 1, 0. I'll need to know how far it is from 1, 0 to 5, 4. And I'll need to know how far it is from negative 3, 4 to 5, 4. I have to have those. You know, I need those side lengths in order to put it into the Pythagorean theorem. So, square root here, we'll do a little math in our head here. Negative 3 minus 1 is negative 4 squared. And 4 minus 0 is 4 squared. Well, that's going to be 16 plus 16, which is the square root of 32. And because of what I'm going to do with that, I don't have to simplify that even if I want to. You know, I don't have to. And that's because what I'm going to do in the Pythagorean theorem is square all this good stuff. So I'd just leave it. I wouldn't simplify it. I'm going to use it for something else. And then for this one, we'd have 1 minus 5 is negative 4 squared. And 0 minus 4 is negative 4 squared. Again, we get the square root of 32. 16 and 16. All right, one more to go. Let's see what we have here. Negative 3 minus 5 is negative 8 squared, and 4 minus 4 is 0. Well, that's the square root of 64. Very interesting. Now let's put that into the Pythagorean theorem. Square root of 32 squared plus the square root of 32 squared, does that equal the square root of 64 squared? 32 plus 32 equals 60. Oh, there it is. Use the converse of the Pythagorean theorem and the distance formula to show that the points negative 3, 4, 1, 0, and 5, 4 determine a right triangle. Well, we use the distance formula right up here. We use the Pythagorean theorem right here. And this is the proof we needed. It is a right triangle. You know, I don't like the it at the front. Let's go ahead and put the given triangle is a right triangle. The given triangle is a right triangle. There we go. You know, you always kind of want to bring everything together at the end and give a sentence that acknowledges a summary of what it was you were trying to do. And that's what we needed to do in that one. This one says, using the midpoint formula, it says, it is a fact from geometry that the diagonals of a parallelogram bisect each other. Prove this with the midpoint formula. Well, how are we going to prove that? Well, if we find the midpoint of each one of these diagonals and it lands in exactly the same spot, then we know that's where the midpoint is. So let's see. We'll use A, AB, and we'll use C, C0, and we'll find the midpoint. Let's see, I'm supposed to do the two x's added together and divided by 2, and the two y's, well, b plus 0 is just b divided by 2. Oh man, that is so ugly. I can't do anything else with that. Nope, you can't. It's okay. That's what it's supposed to be. That's the first midpoint. That's the midpoint, M, of segment AC. Now, let's go after the other one, which would be the midpoint of OB. Thought I was going to do BO there for a second, did you? Not going that way. All right, so now we know that 0, O, is at the origin, and B is at A plus C, B. Add the two x's together. 0 plus A plus C is A plus C, and divide by 2. 0 plus B is B, and divide by 2. Well, look at that. The midpoint of segment AC is the midpoint of segment OB. They landed in the same place. So now, let's write a synopsis. The midpoints are the same point. What does that mean to us if the midpoints are on the same points? Therefore, they bisect each other. We just found the middle of each of those two diagonals, and it was in the exact same place. That means those midpoints are exactly the same, and the diagonals bisect each other. So not a big reach from there. And example 10 says, prove algebraically that a triangle determined by the following coordinates is an equilateral triangle. Ooh. Memory banks, equilateral. All the sides are the same length. Oh, well, we're going to have to figure out the distance from A to B, the distance from B to C, and the distance from A to C to make that happen. We have to show that they're all going to be the same length. So let's see. From A to B. 8 minus 3 is 5 squared. 2 plus 5 squared is a 3 minus 2. Oh, that's going to be 5 squared is a 3 squared. Okay, let's see what that comes out to be. 5 squared is 25. But what happens to this 5 squared? It's a 3 squared business. Well, we can distribute the 2 because this is multiplication. So it'll be 5 squared times the square root of 3 squared. And that's 25 times 3, which just happens to be 75. Square root of 100 is 10. 25 plus 75, it's 10. So we want 10 for all three of these. That is what we are shooting for. All right, B to C. 13 minus 8 is 5 squared. 2 minus 2 plus 5 squared is 3. Don't forget to distribute your negative. That's going to be a negative 5 squared is 3. But we're going to square it anyway, so it's still going to be the square root of 25 plus 75, which is the square root of 100, which is 10. One more to go. Let's see what happens here. A to C. 13 minus 3, that's 10 squared. Uh-oh, are we going to go over? 2 minus 2. Oh, love it. Square root of 100 equals 10. Prove algebraically that a triangle determined by the following coordinates is an equilateral triangle. All three sides of the triangle are the same length. Therefore, that sounds like a summary coming. Therefore, the given triangle is an equilateral triangle. Oops, not trinagle. Oh, I'm having trouble spelling. There we go. All three sides of the triangle are the same length. Therefore, the given triangle is an equilateral triangle. Cool. Cool. Might want to pause it at this point so that you can write all of this good stuff down. That is your assignment that will be due on Monday. Lots and lots of review. Have a great weekend.